The second objective is we're gonna dive into some application of the right triangles using some trigonometry properties. Okay, so given a right triangle, so again, I have a theta, angle theta, radius r, the two legs will be a and b, right? If I want to find side of theta, will be what? Opposite over hypotenuse, right? Opposite here is denoted as a, right? And the hypotenuse is the radius. If I want to solve for a, all I do is multiply both sides by r, right? So if I multiply both sides by r like that, this r cancel. So I have what? A equal r sine theta. And you know where I'm going with this. I can do the same for cosine theta. Right? Cosine theta is adjacent, which is b here, over hypotenuse, which is r. If I want to solve for b, then multiply both sides by r. Same thing, right? R cancel on the right hand side. So b equal r cosine theta, or r times cosine theta. Let me box these because it's important. We're gonna need it later. I also wrote it here for you. And of course, the first one is the Pythagorean theorem, right? A squared plus b squared equals c squared, or r squared in this case, right? Okay, examples. Now let's solve some triangle ABC. Given that triangle ABC is the right triangle, I mean one of the corner is 90 degrees. It has the radius is 12. The two legs A and B is unknown. The angle is 30 degrees. So I want to know I want to solve for A and solve for B. Using the formula above, I know that A equal r sine theta. Okay, r is the radius, which is 12. Sine of theta here, the angle is 30 degrees. 30 degrees. Well, side 30 degrees is 1/2, right? So 12 times 1/2 is 6. I don't know what the units, so I'm just gonna say unit. So that's A. Now B is r cosine theta. Again, radius is 12. Cosine of 30 degrees is √3/2. So I have 6√3 units. Read that for number 1. Okay, number 2. This is a story problem. This is the last one of our session. A giant redwood tree casts a shadow of 532 foot long. Find the height of the tree if the angles of the elevation of the sun is 25.7 degrees. So let me zoom in the picture here. So they're looking for the height, right? They're looking for y in terms of x, y, r. You know. So I know that the adjacent is 532 feet. My theta is 25.7. Right? However, I don't have r, right? In order to solve for h, I need r because h is basically that's your y, right? Or your a in this case, you look up here, that's your a, right? Maybe I should just say y there instead of a. So I know that h is equal, think of a as your a, h equal r times what? This sine, right? The height will be the sine, so r times sine of theta. Well, we want to solve for h. We have theta, but we don't have r. We don't have r. We're going to find r first. Well, this h is equal what? R times sine of the angle is 25.7 degrees. But we don't have r. So we're going to find r first. Okay, we have x. I mean, x is, if you, in trigonometry, when you think of x, relate yourself to cosine, right? So I know that cosine of theta is equal to x over r. Well, this bit right here, that's your x. That's your x, right? So all you do is solve for r, multiply both sides by what? By r, or r over 1. You want to do that. So this implies x equal what? R cosine theta. Plug it. Oh, I'm sorry. We're solving for r. Oh, I'm sorry. We're solving for r. So we're solving for r. So let me do this. Multiply both sides by r. How's that? I'll do slowly. Yeah, multiply both sides by r. So that I have r cosine theta equal x. We're going to solve for r. So divide both sides by cosine theta. Oops, sorry. Try to keep track. Okay, so r equal x over cosine theta. And now we know what x is. We know what theta is. Plug it in, we can find r. Once we have r, we can find h. So x is 532 feet. Cosine theta, the theta here is 25.7 degrees. If you plug it in, you should have the answer of 590.4046 feet. Well, that's your r, right? All you do is to plug in for h here. So now I'm solving for h. So this bit here can finally be done. So h equal 590.4046 times size of 25.7 degrees. The answer is 256.03 feet. So this is 256, roughly 256 feet, which just makes sense, right? It's kind of makes sense. When you solve these story problem, make sure your answer makes sense. If you have something like 5 or 6 feet, it just doesn't make sense. First of all, it's the giant redwood tree. It's gotta be really tall. Let me box my answer, and that will conclude our seminar session today. Thank you for listening.